Hello friends, welcome back to our channel. Today, in part 3 of Mastering Multithreading series, we'll explore the challenges of passing data through thread function efficiently while maintaining type safety. We'll walk through examples and approaches so that our multithreading applications run smoothly without unexpected errors. So, before we get started, just a quick reminder to subscribe my channel, hit the red button and don't forget to click on the little bell icon. That way, you'll be notified every time I upload a new video. Okay, without any further delay, let's get started. Efficient data passing to thread function in C# type safe approach. Before having a look how to pass data to thread function efficiently in a type safe approach, we see the issue that we face with parameterized thread start delegate while passing data to the thread function. As we know, multithreading in C# is a powerful tool, but comes with its share of challenges. One common issue is encountered when using the parameterized thread start delegate while passing the data to the thread function. By default, this delegate isn't type safe as it operates on the object data type. This means that although our code might compile without errors, we might face runtime errors due to incompatible data types being passed to the thread function. Okay, let's try to understand with the help of examples shown over here. So here there is a class named program that has main method, which is an entry pointer of this application. Here I am creating an instance of the thread class. What I have written, thread t is equal to new thread, new parameterized thread start program.print_. You notice I have written program.print_. Print_. number is a static method. That's what I have added class name over there in order to access this print_. I have written program.print_. This print_. number is going to accept object nullable input parameter. Whatever the object that we are receiving, we are converting into int data type. That's what I have written, convert.toInt32 obj. The output, whatever we are going to get, we are storing into this I variable. So I'm converting object to the int and storing into the I variable of the int data type. Finally, in order to calculate the square number, I am multiplying I with I. And that's what I have written, I into I. Whatever the value that we are receiving, we are storing into the result variable of the int data type. This console.writeLine statement, what I am doing, I am just printing this statement into this console window. Square of I and result, whatever the square value that we are stored into the result value, we are going to get printed into this console window with the help of console.writeLine statement. If you see, I have written t.start high. This is the way how we are going to pass the data to the thread function with the help of parameterized thread start. In a start method, we need to pass this parameter. Here I am passing parameter high value. High is the string data type. Print_. number is going to accept object nullable data type. It's okay to write. But if you see this print_. number method, inside every calculation is happening based on this integer value. Ideally, this print_. number should get integer value in order to process it correctly. But here I am passing a high value to it, which is nothing but the string value. Okay, whatever the value that we are going to receive into this object, we are trying to convert into the int. Being a string value in the object data type, it is not able to convert it. That's what it's throwing the error. What is the error it is throwing? It is throwing system.format exception. Input string was not in the correct form. This error we received. So as print_. number is not a type safe method, that's what this error is bound to happen if we are not passing compatible data type. This can be frustrating to debug, but don't worry, as we have effective ways to address this issue with type safe approach. Here we are on Visual Studio. Here we are going to see the demo of the issue with the parameterized thread start delegate while passing data to the thread function. For that, I have created one console application data passing type safe approach. In it, we have one program.cs. Program.cs file, there is a class named program that has main method. As a first statement, I have written this statement, issue with parameterized thread start delegate. So I'm just giving the demo for this. So for that, what I have done, I have created an instance of the thread class. Thread t is equal to new thread, parameterized thread start. And here I have passed this static method. That's what I have included program class name over here. So that's what class name is a program.print_. If you see this print_. number, it is going to accept object data type. Here we are converting this object to the int. If it is having the object is int, then conversion will happen successfully. Otherwise, it will throw an error as a system format exception. If it is the correct, then what we are doing, we are just calculating I into I in order to get this star number and storing into the result variable. Finally, I am printing this statement in console. Okay. Now let me pass correct value to it. I'm just passing 2. Here, if I'm passing 2, and I'm just going to execute this program, I will be getting the output without any error because I have passed the compatible data type. So output got appear into this console because I have passed this data correctly. We are able to successfully convert object that is having the integer value into the integer, and that's what we are able to get the data. But let's suppose instead of 2, I'm just passing I, which is a string value to it. This is object, so it's okay to pass. So we won't be getting compile time error, but we are going to get the runtime error. Let me execute this program and see this error. See, I got this error, system.format exception. Input string was not in a correct form. This is the issue we are facing with parameterized ThreadStart Delegate when we are passing data to the thread. Type safe approaches passing data safely to thread function. There are mainly 3 type safe approaches for passing data safely to thread function in C#. What are they? First, using object-oriented approach. Second, using Lambda expression. Third, using async await with task approach. In object-oriented approach, we can create a class that encapsulates the thread function and the data we want to pass, and use ThreadStart Delegate and pass the thread function name into it. Using Lambda expression, we can capture variables in Lambda expression and pass them to the thread function using async await with task. This async await pattern is more powerful for handling asynchronous operation and efficient for passing data to thread function safely. Okay, let's see one by one with example. Passing data safely to thread function using object-oriented approach. This is one of the approaches to ensure type safety while passing data to thread function. In this approach, we'll encapsulate the thread function and the data we want to pass into a class. Okay, let's try to understand with the help of examples shown over here. There is a class named dataHolder that has int I variable declared over here, and we have defined a constructor to initialize our data and a method print a square number to perform the required operation. So this method is going to perform this square operation and print this statement in this console window. That's what this print a square number is doing. Now there is another class named program that has main method, which is an entry point of this application. Here is a variable named num of in data type. I have initialized 5 value to it. Now I have created an instance of the data holder class. But I have written data holder obj data holder is equal to new data holder and num. Here I have passed num value to it. Keep in mind only integer values is allowed over here. Now by using the ThreadStart Delegate, we can pass the print square method to the thread constructor without worrying about incompatible type. That's what I have written. Thread t is equal to new thread start obj data holder dot print square. Finally, I am starting to the thread with the help of a start method. This way, we have achieved type safety. Our multi-threaded application can now pass data without encountering unexpected errors. Okay, let's switch to the Visual Studio and see all this thing in action. Okay, so here we are on Visual Studio. Here we are going to see the demo of the passing data safely using object-oriented approach. For that, what I have done, I have created one console application data passing type safe approach that has program.cs file. Program.cs file, there is a class named program that has main method, which is an entry point of this application. Here I am just printing this statement passing data safely using object oriented approach in console. Then I have declared a variable num in data type and assigned 5 value to it. Then I am creating an instance of the data holder class. But I have written data holder obj data holder is equal to new data holder, and while creating an instance of this data holder class, I am passing this num value in the constructor. Now if you see class data holder, it has I variable of int data type. In this constructor, I am setting this int num and assigning this num value to the local variable I. And in this class, we have one print square number method. In this method, I am using this local variable I value. That's what. I have just multiplying I into I in order to get this square value. Whatever the value that we have received as a part of result, we are storing into the result variable of int data type. Finally, I am printing into console window square of I and then result what we have received. Right? So this statement is going to get printed into this console. That's what this class is having the data as well as the method, and we don't need to pass anything directly to the thread. We are going to use the object oriented approach where this class is going to encrypt the data as well as the function, and in the function we are going to use the same data. Right? So here I have created one instance of this thread class. That's what I have written. Thread t is equal to new thread start obj data holder dot print square number. If you notice, I have passed thread start delegate object instance over here. I did not pass parameterized thread start delegate because I'm not passing any parameter directly. We don't need to use this parameterized thread start delegate. Instead, I have used the thread start delegate, and here I am passed this method name. Print square number is accessible using this object of this data holder class. That's what I have written. Obj data holder dot print square number. Finally, I am starting this thread. This t dot start thread method. If you notice, I have not passed anything into this start method altogether, right? Because we are not using parameterized thread start delegate. So that's how we are going to achieve type safe function. Okay, let me execute this program and show this output to you. Okay, so output got appeared into this console window. If you see, this statement got printed, passing data safely using object oriented approach. And here square of 5, 25 got printed, right? Now let me change this variable. Okay, instead of int, I'm just going to pass a string value to you. See how it behaves. Okay, now I have initialized str with the high value, then passing into the data holder. If you see, cannot convert from a string to int. So this time it is giving the error. If you are ignoring this error and try to compile those things, it will give the error altogether. You like to continue around the no? I'm saying no. See, I got the error. Argument 1 cannot convert from a string to it. Basically, it's making our function as a type safe. Passing data safely to thread function using Lambda expression. Another approach to achieve type safe data passing is by using Lambda expression. This approach allows us to capture variables and pass them to thread function without risking type mismatches. Okay, let's try to understand with the help of examples on over here. So here there is a class named program that has main method, which is an entry point of this application. Here I have declared a variable num of in data type and assigned 5 value to it. Then I'm creating an instance of the thread class. And here I'm using the Lambda expression. Here I'm in Lambda expression. I'm just calling this print square number, then passing num value to it. If you see this print square number, this is the nothing but the static method. That's what I have called with the help of class name program.print square number, and then I'm just pass this method num to it. Right? I'm directly calling this method, and this is nothing but the static method. So it is accepting in data type and returning nothing. In order to calculate the square number, I'm just multiplying I into I, and whatever the result we are getting, we are storing into the result variable and then printing into this console window. That's how we are going to achieve type safety by passing the data to the thread function. Okay, so let's switch to the Visual Studio. See this program in action. Here we are on Visual Studio. Here we are going to see the demo of the passing data safely using Lambda expression approach. For that, what I have done, I have created one console application named data passing type safe approach that has program.cs. In program.cs file, there is a class named program that has main method, which is an entry point of this application. So here I'm just printing this statement into console window, passing data safely using Lambda expression. Next statement, what I'm doing, I'm just creating a variable named num of in data type and I'm assigning 5 value to it. Then what I'm doing, I'm just creating an instance of this thread class. So that's what I have written. Thread is equal to new thread, and in constructor I'm using the Lambda expression. In Lambda expression I'm just calling this print square number method. You see this print square number method over here. This is nothing but the static method. That's what I have called this with the help of the class name. I have written program.print square number and I have passed num value to it. In print square number, it is going to accept only the input parameter with in data type. Whatever the value that we are going to pass over there, it should be in data types. That makes this method type safe function. Then what I'm doing in this method, I'm just calculating a square number by multiplying I into I. I'm storing the value into the result variable of in data type. And finally, I'm printing this statement into console window with the help of console.writeLine statement. Then I'm just starting this thread. If you notice, I have not passed any value into the start method because I'm just calling this print square number method. I'm passing num variable over here itself. There is no need to use parameterized thread start delegate, which is not type safe. Okay, let me execute this program and see this output. Okay, so output got appeared into this console window, passing data safely using Lambda expression approach, square of 5, 25. Now let me do one thing. Let me comment this line and then write string str is equal to I. Okay. And then this str, I need to pass this in print square number. You see, if I hover this, it's giving me error. Cannot convert from a string to int. And if you ignore those things, go and execute this, right? Then it is giving me field errors. So it is saying argument 1 cannot convert from a string to int. This makes this print square number as a type safe method. That's how we are going to pass the data safely to the thread function. Okay, so we just need to comment this, just need to uncomment this. We need to change this variable name over here, and we are good to go. There is no error at all. We have already seen the output with this as well. Passing data safely to thread function using async await with task approach. Using async await with task. For those of you working with asynchronous code, sync await pattern offers a robust and efficient way to pass data to thread function. Okay, let's try to understand with the help of examples shown over here. So here there is a class named program that has main method, which is an entry point of this application. This main method I have defined in asynchronous way. That's why I have used async and await keyword over here. If you are not familiar with async and await keyword in C#, I have already created a dedicated video on this topic. Must be seeing its link at the upper right corner of this video. Don't worry, I will give its link in this video's description as well for your quick reference. Okay, so in this main method, I have declared a variable num of int data type and assigned 5 value to it. And then I am calling this method print square number async and then passing num value to it. You see this print square num async method, it is accepting the int data type. So whatever the value that we are passing from here, it is going to get accepted by this print square number async. What I am doing in this print square number async method, I am just making this task to delay for 1000 milliseconds. That's what basically I am stimulating async work over here. That's what I have written await task dot delay 1000. Then I am just calculating the square number by multiplying this I with I. Whatever the value that we are receiving, we are storing into the result variable of int data type. Then I am printing into this console window. That's what this print square number async method is doing over here. If you notice, this print square number async is going to accept the int variable, and here we need to pass the int variable over here. If you are not going to pass the int variable, so we will be getting the compile time error. That makes this method as a type safe. Okay, so here we are on Visual Studio. Here we are going to see the demo of passing data safely using async await with task. For that, what I have done, I have created this console application data passing type safe approach, and here we have program.cs. In program.cs file, we have a class named program that has main method, which is an entry point of this application. I have defined this main method in an asynchronous way, but I have written async and await keyword over. Now in this main method, what I am doing, I am just printing this statement, passing data safely using async await with task. Then I have declared a variable named num of data type and assigned 5 value to it. Then I am just calling this method print square number async and passing num value to it. You see this print square num async method, which is nothing but a static method that is accepting the int data. This is making this print square number async method type safe. We need to pass only the int data type. If we are going to pass any other data type, we will be getting compile time. So what I am doing this print square number async, I am just using this await.task.delay 1000 milliseconds. With this statement, what I am actually doing, I am just stimulating async work over. Okay, in the next statement, in order to calculate square number, I am just multiplying I with I. Whatever the value that we are receiving, we are storing into the result variable of int data type. Finally, I am printing this statement into console window. That's what I have written console.writeLine square of I result. Okay, so let me execute this program and see this output to it. Okay, so output got appear into this console window. You see, passing data safely using async await with task in square of 5. I give the value as 20. Right? So it is working as expected. If you notice in this program, I have not used thread class altogether. Instead of that, I have used async await pattern over here. That's how we are going to pass the data safely. Okay, so that brings me to end of my session. To sum up, in this video, we learned what issue we face with parameterized thread start delegate for passing data to thread function. Then we talked about type safe approaches for passing data to thread function. like object-oriented approach, using Lambda expression approach, using async await with task. So guys, please keep in mind that mastering multi-threading in C# involves not only understanding the technical aspects, but also ensuring type-safe data passing to thread functions. Whether you opt for object-oriented approach, Lambda expression, or the async await pattern, you now have the tools to create robust and error-free multi-threaded applications. Thank you for joining me in this exploration of type-safe data passing in multi-threading. That's all for this video, guys. If you like this video, hit the like button, share it with your friends and colleagues, subscribe to my channel if you haven't done already. Thanks for watching. See you next video.